Hello and welcome to the Daily Space for today. I think it is August 9th, 2019. How are we already in August? Earlier today, I was talking with community member Nancy Graziano over on Discord, and she pointed out that we had all these plans of all of these great things that would all be accomplished this summer. And it turns out I, for one, have spent most of my summer counting rocks because there's too many rocks on Bennu, and we have to find them all and measure all the boulders, and there's a lot of them. So here's my plea to you. Please help me have some of my summer to do something other than look at rocks. Go to bennu.cosmoquest.org and help us map out this little world. We are to under 1,000 images that need to be completed. We can do this. And I've promised the community, because this might work, that if you finish by Sunday, I will get Bennu on my arm forever before TwitchCon. It's a very definitive promise. So go map. Go map. Please, please. Okay. So we have a bunch of news to bring you today. And anyone who appears on camera knows you have to know your angles. Not many can get away with strictly showing their profile, but this galaxy is going to give it a try. NGC 5866 is a disk-shaped galaxy located 44 million light years from Earth, seen entirely edge-on. We know it has a 60,000 light-year diameter, but I can't tell you if it has spiral arms or any other features because it's entirely edge-on. Now, for completely unknown reasons, this 2009 image was released today in a NASA news item in which it is likened to looking like a lightsaber. I have to admit, press releases like this, which contain an old image and a bunch of clever words that don't contain much new information, used to really perplex me. Then I got funding from NASA and began to hear during regular telecons with representatives from NASA headquarters that they needed content to put in front of funders, by which I mean the President of the United States and other governmental officials. So when you see these, why are you telling me this now, press items, it often means they are running low on news, and a call was made and someone said, well, I have this 10-year-old image we never shared and it's kind of cool. So to editorialize for a moment, I have to admit that as a scientist, it pains me that it's so hard to get funding that we have to make up news to keep people happy while we work on actually getting good results. As a science communicator, these items frustrate me because there seems to be an assumption that if you give me a pretty picture, I will happily promote your mission. Well, I'm going to start calling announcements like this and like the gull-shaped gas release we got yesterday for what they are. Pretty pictures, empty of content, meant to advertise missions. Yes, Spitzer and the Very Large Telescope deserve funding on their scientific merits. Yes, it's cool to share pretty pictures simply because they're pretty. This is why I'm on Instagram. I want to see your adorable dog and cat pictures and that really gorgeous garbage plate that you made for dinner. I'm looking at you, Planet X. All I ask is we don't pretend a 10-year-old image being compared to a lightsaber is news. This image had so much potential for explaining science. Images like this have the ability to help us understand the faint structure of the outer parts of disks. Systems like this help us see how the disk and sphere of a galaxy meet and mix. Heck, they could even have gone into the history of this object which is also called the Spindle Galaxy, or Messier 102. This pretty picture had so much potential. Use that potential, people, please. Call this image and images like it what they are, glamour shots. But give them a context that makes us want to learn more and support the continued science these missions can do. Okay, soapbox set aside, on to some more science. So the ALMA, Atacama Large Millimeter Array, and Hubble Space Telescope have once again provided a scientific 1-2 punch that helps us understand supermassive black holes. Gas and dust orbiting in the core of NGC 3258 was observed by the Hubble Space Telescope. That's this, I can't reach through the image, that's the image that you see on the upper left. This kind of gas that Hubble was able to see, particularly the carbon monoxide in this gas, gives off light in millimeter colors that the Atacama Large Millimeter Array is able to observe. And with its super high resolution that really kind of puts Hubble to shame, ALMA was able to measure the velocities of that gas in the inner 500 light years of this system. NGC 3258 is a massive elliptical galaxy about 100 million light years from Earth. Using these remarkable observations, astronomers calculated this galaxy's central black hole weighs a staggering 2.25 billion solar masses. The thing that makes this press release worthy is that ALMA was able to get such high resolution, low error bar measurements of a system so far away. Over time, we need to gather dozens to hundreds of these kinds of measurements to really understand the relationships between galaxy characteristics and the characteristics of the black holes they contain. This observation demonstrates this is going to be possible. But it doesn't exactly get us all the way. There's so much left to learn. And this is showing us pretty data. Well, okay, fine. It's kind of ugly. Telling us what it means, telling us why it's important, and inspiring us to look forward to the next, news note, press release, and publication that continues to tell this story. All right. In our next story, coming to us from the Chandra X-ray Observatory, we learn that black holes, can use Chandra? Here, I jest, but folks, I prepped for this show while drinking my first cup of coffee, and the lack of punctuation in this headline made me think, how did this system time travel, grab Chandra, take it back in time, and then get us its data? This may say more about me than about the press release, but I think maybe what they meant to say was NASA's Chandra X-ray Observatory discovered a cloaked black hole residing in the early universe. Light takes time to reach us. And when we observe objects that are extremely far away, we're actually seeing light emitted extremely long ago. While observing an active galaxy, one with a supermassive black hole in its center that is surrounded by a bright accretion disk of infalling material, astronomers led by Fabio Vito of the Pontificia Universidad Católica de Chile, I think that translates to the Chilean Pontiff's University or Catholic University. They looked to see if they could find evidence that the systems from the most distant universe showed signs of being enshrouded by gas. So finding systems like this is key to understanding galaxy evolution. As we talked about yesterday, it's thought that the most active galaxies, these are quasars, they evolve from having a gas-filled core to blasting that material out to shine bright and blue. The still enshrouded galaxies, when we see them, will we think be red? Maybe. But finding the farthest of them will be tricky because they won't be as bright as their non-enshrouded siblings. Vito's team used the Chandra X-ray Observatory to look for X-ray light from a series of distant quasars found optically. If they could find systems with little to no low-energy X-ray emission, but that had high-energy X-ray emission, they would know these systems were enshrouded by gas that was obscuring the low-energy X-ray emission, but was unable to block that high-energy X-ray emission. Put another way, when you see smoke, there's a good bet there's fire, and when you see high-energy X-rays, it's a good bet there's low-energy ones that are just somehow getting blocked from our view. The thing is, sometimes there isn't a fire when you see smoke, and sometimes the quasar isn't obscured, and this is what's so frustrating about doing science. In this case, the galaxy in question, PSO 16713, don't let astronomers name stuff. It has a nearby a nearby companion galaxy, and it's possible the source of the three X-ray astronomers name their photons. The 3 photons the Chandra X-ray Observatory detected during 16 hours of observation weren't from the quasar, but were instead from its companion galaxy. If it isn't the source, if the quasar isn't the source, then this system is one that is deeply confusing, but not unusual. But if it turns out that this quasar is the source of this high energy photons, we need to understand more and do a lot more observations, because somehow this optically bright system is enshrouded in gas and dust that are blocking the X-rays. And you're supposed to have either enshrouded blocking all the light, or not enshrouded, not blocking light. And it's possible that in the months between the optical observations and the X-ray observations, the system changed. So more observations are needed. And this is one of those systems that's kind of cool, because once again, our universe has decided that our models are not the boss of it. And it is going to shine light how it wants to shine light, and it's up to us to figure out how it's, pulling photons out of systems in these weird and wonderful ways. So here, no pretty pictures, lots of pretty science. These are the releases I live for. But most of what we were getting today is pretty pictures. Returning back to our own solar system, NASA has, in collaboration with ESA, released a pretty set of pictures that they turned into a video. I would like to play the video. Hello, YouTube. There we go. This video is a compilation from a myriad of Hubble Space Telescope images taken during this year's closest approach of the Earth to Jupiter, with our Earth and this gas giant both lined up with the sun during Jupiter's opposition. Hubble was able to get high-resolution full disk images of Jupiter that are glorious, and not something that the Juno spacecraft can do from its position so close up to Jupiter. Once again, we need to wait to see what science might come out of this, but it's pretty. And I do have some science to go along with it. As some of you may have, I lost my mouse. As some of you may know from social media and services like Science Alert, Jupiter has once again been attacked by an asteroid or comet that exploded in its outer atmosphere. This video, I'm not actually showing you the video, I'm showing you a still from a video that came to us from Ethan Chappell, an astrophotographer in Texas who caught this event while taking video to observe the Perseid meteors. It's thought that that bright spot on Jupiter is an impact that was probably too small to generate the dark splashes of material we sometimes see. But folks are still on the lookout to see what might be seen as Jupiter turns, to re-reveal the point of this impact. The thing I love about this observation and ones like it is it shows us two things. One, Jupiter is under constant attack. And two, it's possible for anyone to get lucky and catch one of these events. Back in 1994, when Shoemaker-Levy 9 impacted Jupiter, we thought that impacts like this were a once in every several hundred years kind of event. Now, with high-quality digital detectors affordable to middle-class telescope owners, we're seeing impacts almost every year. If we are accidentally catching multiple impacts this regularly, it could be that Jupiter gets hit multiple times per year instead of the once per multiple centuries we used to think. This is just kind of awesome. Well, except maybe for Jupiter. But I, for one, hope that maybe even some of you are able to catch these impacts during your own future observations. And that's all I've got for today. It has been a crazy week around here at CosmoQuest, and I'm so grateful for all of you sticking around and staying with us through all the chaos. And I'm now going to figure out how to answer your questions, but before I do that, I'm going to remind all of you that this show, The Daily Space, comes to you most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That's 6 p.m. London time. We're hosted by myself, Dr. Pamela Gay, and by our own binary ablaze, Annie Wilson. She comes to you most Wednesdays, bringing you rocket updates, and then returns on Sundays with the Sunday Science Hour. We also bring you, whenever we can, launches, landings, and all the science announcements in between as they happen. So give us a follow. Follows are free, and it will help you find out whenever we're going live with whatever the universe has to offer. We are produced by Susie Murph, who edits together our videos for posting over on YouTube. If you miss us live here on twitch.tv/CosmoQuest, well, click on over to YouTube and catch us at youtube.com/c/CosmoQuest. I think there's a consistency in URLs there somewhere. We are a production of the Planetary Science Institute, working in collaboration with Youngstown State University. And we are brought to you by you. We are so grateful for all the generous people who sponsor us over on Patreon, requiring us to show you ever smaller and smaller names. I'm going to figure out how to animate that to show you during stream. Your tax-deductible donations are what allow me to pay our staff a living wage. But we understand people can't always give, and that's okay. There's lots of other ways you can help the show. The best way you can help is by doing science. Go on over to benu.cosmoquest.org and help us with those rocks. It's all right to hate map. We all hate the rocks at this point. We just have to do the work. Please map rocks, people. Please map rocks. All right, that's all I've got. I am now going to try and find on the other side of the room where on this really zoomed in window the chat is hiding. Pardon me while I scroll around. Oh, crud, am I on the wrong window? I might have just accidentally eaten the chat. I did. Crap, I don't have the chat because I accidentally slid sideways with 2 fingers and erased the chat in how I scrolled. And Twitch is unforgiving in letting you have your chat history. Dear Twitch, I hate you right now. Okay, so if you typed a question in earlier, please type it back in again. And I will answer it. Hello, Hanny's Vorverp. Okay, so Larry is asking, Jupiter's radiation, is it mostly indigenous or captured from the sun? It's a little bit of both. Its infrared light is actually in excess of what it's receiving from the sun. Jupiter is a hot ball of gas. It's not a hot ball of plasma like our sun. It's a hot ball of gas, but it's so big that as gravity presses in, it's increasing the heat of the gas with gravity, and that gravity-generated heat is getting radiated away into space. So it's a little bit of both. So Hanny is asking, what is causing the fog around the lightsaber? Is it intervening gas? So let me go ahead and go back to the lightsaber image. This is that galaxy that we showed at the start of the show. So here in galaxy NGC 5866, you see in the middle bright orange infrared observations made by Spitzer. I guess they're actually bright pink. That is the highest concentration of gas and dust in the disk of the galaxy. Now, while disks have this thin component that is high density, they also have this thicker, lower density component of gas and dust, and some stars that extends a much larger distance. What we're seeing is that extension of gas, dust, and stars in the thick disk and in the spheroid around this galaxy. Our own galaxy has the same halo of material all the way around it. Okay, let's go back and see what other questions I can find. Susie asks, does NGC, I need to make this bigger, 5666 have a halo? Is that confirmed? And how about dark matter? 9866. Yes, it does have a halo, and it is confirmed. And Crossbound, thank you for subbing with Twitch Prime. Thank you so much. Susie says, from Hanny, Chandra is X-rays. With the square kilometer array, will we be able to see early black holes as well? So we don't ever actually see black holes. What we see is the material around them. The accretion disk in the case of the high energy system that I was talking about earlier. Here you can actually see in optical light the extended parts of that disk of material. And that disk is radiating energy across many, many different colors. And just as we use the Atacama Large Millimeter Array to zoom in on the center of this galaxy, we'll be able to use the Square Kilometer Array to essentially zoom in on the centers of many other galaxies. Now, with the Chandra X-ray Observatory, what they're looking for is a combination of systems that have the gas and dust in the center, but also have a enshrouding layer of gas and dust that is blocking the low energy X-rays, but which the high energy X-rays are able to pierce. That was in our other story of the day. Actually, is that the correct image? Yes, that's the correct image. So we will be able to see all of these with the Square Kilometer Array, but we get different science by looking at these things in different colors. Also from Hanny, what is causing the fog of... Okay, so I already got that one. So Nathan Dahl asks, did the meteor hit actually damage or displace what makes up Jupiter? I don't know how to clarify damage. It did move it around. It did chemically change some of the molecules with its heat. I don't know if you call that damage. Our own Earth's atmosphere gets hit by a couple of tons of space debris every year, and of course by our own debris from falling satellites. And we see this lighting up. We sometimes see gas getting ionized in the process, but we don't really think of it as damage. It's just the way material gets processed through our universe. Veronica Cura asks, or says, birthday shout out to our own Guido B. I hope you're having something awesome for dinner and are maybe not here watching and are out with friends, Guido. Happy birthday. Let's see what else. So Larry goes on to ask, do black hole accretion disks fuse iron and heavier and larger nuclei? It depends on what processes are going on, but yes, there are not at the same scales that you get with supernova on an ongoing basis, but you do get bursts of ignition, of lighting up of material, and you do have nuclear reactions going on. And as to its presence in the jets don't generally have a high enough density to have ongoing nuclear reactions, but there can be different processes that occur in the jets. For instance, if atoms are getting bombarded with neutrons during a supernova explosion, processes are possible. It's just not ongoing reactions. Hello, Tom Van Scooter. I like the way you put that. It was a flesh wound, referring to the meteor strike or comet strike. We don't know which on Jupiter. It's but a scratch. I agree. And now we have devolved to Monty Python. I love Monty Python. Oh, you are here, Guido. And you're having spaghetti bolognese for dinner. That is awesome. Okay, hi, Planetary Pan. You did have a press release coming out of SETI yesterday. I have to admit, I didn't cover it. And I'm trying to remember why. There was a reason when I looked at it. I think it was an announcement of an upcoming instrument, and I generally don't cover upcoming things, simply because there's too many opportunities for the funding to get cut before they actually get done. Yeah, the X-ray can be truly beautiful. It really can. All right. That's all the science I've got for today. I will probably be rage coding our Bennu Mapper software later today. I'm going to put it public first, so we will actually be an open source project starting today. And then I'm going to be continuing my war against the database, trying to get data out of it before it times out. The coding won't be pretty, but the results sure are. So please help me map. Help me break my database because, well, the database is fine. Help me break my software that is trying to get all the data out of the database. Together we can do this, people. Together we can do this. So this is all I've got. And once again, I'd like to remind you, the Daily Space is hosted by myself, Dr. Pamela Gay, and by Binary Ablaze, Annie Wilson. Our episodes are produced and edited by Susie Murph, and we are a production of the Planetary Science Institute working in collaboration with Youngstown State University. We're brought to you by you. Your funding lets us do the things that you see here, from buying the software that we need to, well, paying Susie and Annie a living wage. So thank you for everything that you give. And if you can't make a monetary contribution, that's okay. Tell your friends, tell your family, tell your enemies, get more people learning and doing science. And please, map rocks. Map rocks, people. Map rocks. All right. Can someone suggest somebody to raid? I don't know Who's currently streaming? I thought I saw someone go live earlier, but I left my phone upstairs, so I can't click on over to my phone to double check. So suggestions welcome on who to raid. EJSA is streaming, and it's supposed to be good right now. That is good to know. I shall raid them. Thank you. I have a keyboard that is hidden underneath because for some reason it's trying to green screen my keyboard. All right. So as always, wherever you are in the world, have a fabulous morning, evening, or afternoon. And get outside and look up. And happy birthday, Guido! Happy birthday.